In the last video, we saw how to make our types polymorphic. That meant applying them to many types. Now we did this by taking the type that was there, we had a look at the function code and saw if it relied on any specific behavior from a type, and if it didn't, we replaced the type signature with something arbitrary. You can see I've got 4 functions here, which all have an arbitrary type, except from maybe their return type. So this one takes an A, and returns a boolean. This one takes 2 A's and returns an A. This one takes 2 A's and returns a boolean, and this one takes 2 A's and returns a list of A's. So I've made these types very, very generic. Now, there is a problem with being overly generic. We might not have the behavior for every type that we need to write that code. So, for example, up here I have x equals y, and I've made that available for any type A. Now, not every type can be tested for equality. For some things it doesn't make sense to test for equality. So it wouldn't make sense for me to say this can be any type, and in fact I am getting an error here because the double equals, the equality, is not applicable to any type. So what did I do? Well, if I come down to terminal here and I use :t and then double equals, I can see that this function has something funny going on here. Now, anything to the left of an arrow like this is what we call a type constraint. That means that the type has to satisfy the condition to the left. Now what this one is saying is this has to be part of the equality type class. Now, what is a type class? You can think of a type class as something like an interface from Java. So an interface in Java, you say for an arbitrary type, it has to be able to instantiate a bunch of functions. We saw in CS207 when we did the array stack, it had to have to apply instantiate the interface, it had to be able to apply the pop, push, top, size as empty methods, and that's kind of what a type class is doing. A type class is saying it the type A has to fulfill the functions that are part of this type class in order for this function to work. So let's have a look at the EQ type class. Now, we can't use :t to find a type class because a type class is a bit more a higher order than a function. So in this case we'll use :i and we'll have a little look at EQ. Now we get a whole lot of instances here, and this is for different types of things that can be applied to EQ, so this is some of the instantiations of EQ. But if we go up to the top, we see that EQ is a constraint, and there's class EQ where we have the equals, the equality function, which takes 2 elements of A and returns a boolean. And then we have the not equals, which is something that takes 2 A's and returns a boolean. So these are the functions that a type A has to instantiate in order to be part of the equality type class. Now down here you can see that there's something called minimal, and this is the minimal definition for this type class. So for something to be part of this type class, the minimal thing you can give it is an instance of how the equals function works or how the not equals function works. Now that makes sense. If you give it the equals function, we can easily find the not equals by just applying the not logical negation to it. So that's an easy way to get both functions for the price of one. So if we want to use these functions, the element A has to be part of equality, and that's what's going wrong up here. You can see if I hover over this, I'll get an error saying no instance for EQA arising from a use of double equals, and that's a bit of a vague type error, but what it's saying is, oh, you've not actually said that A has to be part of the equality type class, so we can't necessarily use this double equals function. What I can do is go up here, put in EQA, and there we go. Actually, if I typed in properly, there we go. And now the error is gone, because now it says, okay, for any type A, as long as it's part of the equality type class, we do this. Now down here, I've got a similar issue in that I've got x plus y, and it says no instance arising for num from use of plus. Now that's sensible. I mean, we can't add any arbitrary type together. What does it mean to add a boolean together, or to add strings together, or even more complex types? How do we add them together? Well, we can't necessarily. So again, if you have this issue and you get that weird error message, it's worth going in here and having a look at the function that's causing the error, and it's saying this is part of the num type class. Now again, we'll have a quick look at this. We don't have to understand everything that's going on in the num type class, but if we have a quick look, we can see that this is where we have instantiations for all of these functions for the type A. So we have to have all of these in order to be part of the numeric type class. Now it makes sense that we would restrict the things that you can add together. So it's a very sensible list of requirements. So anything we can perform arithmetic on could be part of the num type class. So up here, say num A, and then the error goes away again because we've constrained A only to the types that have an instantiation for this plus operation. So any type that doesn't have an instantiation for this plus operation is going to fail the type check up here. Again, similarly down here, this is saying that we have no instance of the orderable type class. Now the orderable type class is one which has a greater than or a less than or greater than or equal to instantiation. So again, we can fix this by saying ord A, and that restricts A's to the operation or to the types that have an instantiation for this greater than operator. You'll find that for most operators, we have to have them, and they have to be part of some sort of type class. So all of these operators, the ones that are generally applied in infix notation, plus, equals, greater than, they all have to be part of specific type classes. So you'll generally find that with operators. Now this one might be less clear. So this one says generate list, and it says take two elements of A and return a list of A's. And it says for an X and Y, start the range at X and go up to Y. Now this would make sense for integers. If you say start at 1, go up to 10, you would expect to get the list of 1 up to 10 back. It kind of makes sense for characters. If you say A and Z, then you get the list which is A's up to Z's. But this is not type checking because we're missing a type class. Now, the type class that we happen to be missing is the enumerative type class. This is a type class for types that can be ordered. So types that have an order with them. So you can think integers, they have an order. 2 is greater than 1, 3 is greater than 2, 4 is greater than 3, so on and so forth. So again, might not make sense to apply this to say booleans or strings, but any type that can be enumerated over, any type that can be ordered, can be part of this type class. And so we put in enum A. Again, we could have figured this out by hovering over the error message and then restricting, but I know what this type class is, and I've used it before, so I understand that that's what should be going in here. And now all of our errors have gone away, and all of these are valid Haskell code. So the thing to be aware of, these are some basic type classes. We'll probably see some other ones as we go along. We'll see a little bit more about how they work and how to use them when, say, you're defining your own types. But the real thing I want to get across to you today is sometimes it makes sense not to be too abstract. Sometimes it makes sense to restrict and constrain the types that you're working with. We don't need to necessarily know right now all of what's going on inside these. I just want you to get an idea of some operators have to be part of a specific type class before you can use them, and that some types need to have an instantiation of those functions before you can start calling them on generic types. That's everything for today. We'll see more examples with type classes as we go through this course. I just wanted to give you a rough idea of what they are, what they do, and why they're useful. So if you have any questions, please do feel free to get in touch. Thanks.